All right, so test tomorrow's on 3.1 through 3.4. For your test, make sure you know the stuff from the quiz. You will have questions on the test where you have to graph, so there's none on the review. But look back at your quiz review. I gave you back your quiz, so look at those so you don't make the same mistakes that you made on the quiz. So the quiz was 5 questions. Test is going to be 11. So you're going to have the same stuff from the quiz plus more questions. So make sure you know what you're doing so you can work in a timely manner. Let's take a look at, we'll do a couple expanding and condensing ones. So let's do number 5. So when we expand, what goes with division? Subtraction. So this would be log of x minus log of y to the 5th power. And then any exponent we have, what do we do with it? Move it into the front. So log of x minus 5 log y. Let's do 6. So we're multiplying here. What goes with multiplication? Addition. Perfect. So when we break these apart, we have log of x plus log of y plus log of z squared. What do we do with the exponent? Any questions here? All right, so remember, multiplying goes with addition, division goes with subtraction. Let's condense in number 7.
Could you do number 3?
Yes, we could do number 3.
I saw like it said 1 minus.
So because here we're dividing, so we're going to subtract. But because the exponent is being applied to both numbers, you can either distribute it to both of them now or move it out front and then separate it with division, either way. But just make sure you know that that 6 power is being applied to both of them. So we have log of 6 to the 6th power minus log of 5 to the 6th power. So then any exponents we have are going to go in front. So 6 log 6 minus log 6 log 5. If we had log base 6 of 6, this would cancel. But this isn't the same. That 6 is a coefficient. All right, we'll do a condensing one. So let's do number 7. So any coefficients we have are going to go up top. So we have log base 6, and when we add, that means that we multiply. So log base 6 of x times y times z to the 6th power. If you put this all in parentheses, that would be okay, but you'd have to put them like that. But you don't need the parentheses when you're multiplying. If you had, like, let's say log base 6 of x plus 2, here you'd want to put the parentheses around it if you were adding a number to it. All right, let's do 8. So any coefficient that we have is going to go up top. And then when we add, we multiply. When we subtract, we're going to divide. So anything that's negative is going to go in the bottom of our fraction. So here we have log base 2 of x to the 1/3 power times y to the 3rd power over z to the 7th power. And then how else could I write the 1/3 power? The cubed root. It's the cubed root of x times y to the 3rd power over z to the 7th power. Either way is fine if you want to leave it as the 1/3 power, but I'm writing it this way because you might see one where you have to expand, but then you'll have to make the 1/3 your coefficient. So if I had, let's say, log base 2 of x to the 1/3 power, when we're expanding, you want to move the 1/3 in front. So if this was, instead of the 1/3 power, if it was the cubed root, you want to change it to be the 1/3 and move it in front. So if you are condensing, you can leave it as an exponent or the cubed root, but if you're expanding, you want to move it to be a coefficient. So make sure you know that that is an exponent. Questions there? All right, let's do some solving questions. Let's look at 11. What would we do to solve here? We want to get the base with the exponent all by itself first. So what would I have to do? Add 14 to both sides. So 3 times e to the power of x equals 25. What should we do next? Divide by 3. So e to the power of x equals 25 over 3. What should we do next? So we're going to take the ln of both sides. So ln of e will cancel, and we're just left with x equals the ln of 25 over 3. And then this we just have to put into our calculator. You should get 2.120. Let's do 13. How do I get rid of that log? What's the base of our log here when no base is written? What's it implied? 10. So if our base of the log is 10, what do we need to make the big base to cancel out with that? 10. So I'm going to make our base 10 on both sides. So 10 to the power of log base 10 will cancel. So we have 3x plus 1 is equal to 10 to the second power. Essentially what I'm doing is just putting it into exponential form. Starting with the base, switch the other two numbers. So 3x plus 1 is equal to 100. From here we just solve for x. Subtract 1. 3x equals 99. Divide by 3. X equals 33. Let's do 15. What should I do for 15? So if you can get it to be an ln equals an ln, try to do that. But here we can't, because if I were to add the ln of 3 to the right side, it wouldn't be all by itself because we have that 4. No. We can condense it. So we want to condense it down to a single ln, then we can put it into exponential form to solve. So when I subtract, what goes with subtraction? Division. So the ln of x over 3 is equal to 4. Now how do I get rid of the ln? E, I'm going to make the big base e on both sides. So e to the power of ln is going to cancel. We have x over 3 is equal to e to the power of 4. From here we can put it in our calculator. E to the power of 4 should give you 54.598. It keeps going, but I'm going to leave it in the calculator. And then the last step is just multiply it by 3. So x equals 163.794. All right, what about 17? What should we do first for 17? I can divide both sides by 2. So ln of 3x is equal to 2. The other thing that you could have done here is made that 2 an exponent. But be careful, it would have been 3x squared. So the 3 would be squared and the x. But we just divided it by 2, moved it to the other side. So we got rid of it. So you could either make it an exponent or divide it over. Either way will work. What should we do next to get rid of the ln? Make the big base e. So e to the power of ln cancels. We have 3x equals e squared. So let's put it in the calculator. E squared would be 7.389. It keeps going, but I'm going to leave it in the calculator. We don't want to round in the middle of the question. Then divide by 3. We get x equals 2.463. All right, what should we do for 18? So when x is in the exponent, we're going to use logs to help us solve.
Log base 3.
So I'm going to take log base 3 of both sides. Or just put it into log form. We're doing the same thing. So log base 3 of 3 will cancel. We have x equals log base 3 of 500. How would I put this in the calculator?
Log, open parentheses, 500, close parentheses, and then over log 3.
Awesome. So log of 500 over log of 3. Remember, the base goes on the bottom. When you put this in the calculator, if you do it all at once, make sure you close the parentheses to the 500. So I'm going to do log of 500, close the parentheses, divided by log of 3. So you should get x equals 5.657. What should we do first for 19?
Log base 5.
Awesome. Since we have an exponential question, we're going to use logs to help us solve. So log base 5 of both sides. So log base 5 of 5 will cancel. We have x plus 2 equals log base 5 of 4. So x plus 2 equals log of 4 over log of 5. Remember, the base goes on the bottom. So in my calculator, I'm going to do log of 4, close the parentheses, divided by log of 5. So x plus 2 equals 0.8613. It keeps going, but I'm going to leave it in the calculator for the last step. We're going to subtract 2. So x equals negative 1.139. So 20 looks a little bit different. Here we can't combine the e to the power of x's to just be 1 e to the power of x because they're not like terms, since one of them's squared and one's not. But this is super similar to if it were 2 x squared minus 5x minus 3. But instead of x's, it's e to the power of x. How would we solve something that looks like this? Easier than quadratic. Factor. Let's see if it'll factor. So how would I factor this? What do we do when our leading coefficient's not 1? Multiply the first times the last. So 2 times negative 3 would be negative 6. What are 2 factors of negative 6 that add to negative 5? Negative 6 times 1. Perfect. So we have, instead of x minus 6 and x plus 1, it's going to be e to the power of x minus 6 and e to the power of x plus 1. But if we started with multiplying and we don't group them, what do we have to do next? Don't forget to divide by 2. If you start by multiplying the 2, you have to divide. So we have e to the power of x minus 3 and 2e to the power of x plus 1. Now you can always check your work when you FOIL this way, or when you factor this way, by FOILing. If I were to FOIL this out, I would get the original question, so you can check it. From here, we're going to solve each one of these like their own separate equations. We're going to set them equal to 0. E to the power of x minus 3 equals 0. 2e to the power of x plus 1 equals 0. How would I solve the first one? E to the power of x minus 3 equals 0. We're going to add 3. Move it to the other side. E to the power of x equals 3. We're going to take the ln of both sides. Perfect. Ln of e will cancel. So x equals the ln of 3. So we can just put that in our calculator. Ln of 3 is 1.099. Let's do the same thing with the other one. So here, what do we do first? Subtract 1. So 2 e to the power of x equals negative 1. Divide by 2. So e to the power of x equals negative 1/2. What do we do next? We're going to take the ln of both sides. So ln of e will cancel. So x equals the ln of negative 1/2. What do you get when you put the ln of negative 1/2 in the calculator? Domain error. Why do you think? You can't take the ln or the log of a negative number. So here, this one gives us no answer. But it's not no solution as our final answer because we still had an answer here. So our only answer is 1.099. The other one doesn't give us an answer. So anytime you see a question that has e to the power of 2x and an e to the power of x, we can't combine these because they're not like terms. So you want to factor. So keep that in mind for the test tomorrow. So this, well, I'm just saying that this is similar to 2x squared minus 5x minus 3. But instead of x's, we have e to the power of x. So we factored it the same way we would as if it was just with x's, but instead of writing x's when we factor, it's e to the power of x.
But in the exponential, it's 2x, not x squared. So we just make it x squared.
But it's e to the power of 2x. So if I were to multiply e to the power of x times e to the power of x, what do we do when we multiply when our bases are the same? Add the exponent. So this would be e to the power of 2x.
Right.
So if I were to FOIL this back out, I'd get e to the power of 2x. All right, 21 is similar, so let's do that one. What should we do first here? Let's move the 10 over. We know that we have an e to the power of 2x and e to the power of x. They're not like terms, so we can't combine them. So we know that we're going to have to factor. Bless you. So 6 e to the power of 2x minus 11 e to the power of x minus 10 equals 0. So since we have to factor, we have to make it equal to 0 to start. So I'm going to multiply the first times the last. So we get negative 60. What are two factors of negative 60 that add to negative 11?
Is it 15 and 10?
So negative 15 and 4. So we have e to the power of x minus 15 and e to the power of x plus 4. Now, if we start by multiplying, what do we have to remember to do? Divide. So I have to divide by the 6. Simplify the fractions if you can. So how does 15 over 6 simplify? What does it simplify to? We can divide them both by 3, so it'd be 5 over 2. Perfect. The 2 is going to move in front of the x, or e to the power of x. So this would be 2 e to the power of x minus 5. How does 4 over x simplify? We can divide them both by 2, so we get 2 over 3. Then the 3 is going to move in front of the e to the power of x. So 3 e to the power of x plus 2.
Wait, so you take the bottom one and move it to the front?
You move it in front of the x, or here our case is e to the power of x. This is just factoring. We know how to factor. If you don't do it this way, remember the other way is to group them. You could still factor by grouping too. All right, so from here, let's set them equal to 0 and solve. So 2 e to the power of x minus 5 equals 0, and 3 e to the power of x plus 2 equals 0. So in the first one, what would we do to solve? Add 5. So 2 e to the power of x equals 5. Divide by 2. E to the power of x equals 5 over 2. What should we do next? We're going to take the ln of both sides. So it cancels with the e. So x equals the ln of 5 over 2. So we can put this into our calculator. The ln of 5 divided by 2 should give you 0.916.
So everything.
Here, we're going to do the same thing. So 3 e to the power of x equals negative 2. When you subtract 2 to the other side. Divide by 3. E to the power of x equals negative 2/3. Lucerno, what do we do next?
Sorry, I'm not lost.
Valeria, what do we do next?
You put the ln.
We're going to take the ln of both sides. So it cancels. So x equals the ln of negative 2/3. But then we don't get an answer because we can't take the ln of a negative. So this would be our answer. Looking at 22, what should we do first? Divide by 2. We want to get e to the power of x all by itself. So we got to divide by 2 first. So e to the power of 0.5x equals 45 divided by 2. $22.5. What do we do next? We're going to take the ln of both sides. So ln of e cancels. We're left with 0.5x equals ln of 22.5. We can put the ln of 22.5 in our calculator. So 0.5x equals 3.1135. It keeps going, but I'm just going to leave it in the calculator. What do we do next? Divide by 0.5. So x equals 6.227. All right, let's do 23. So what you cannot do here is cancel out all the logs. You can only do that if you have 1 log equals 1 log. So can we make this be 1 log equals 1 log? How? Condense them. We got to condense the left side. So when we're adding, how do we condense? Multiplication. So log base 7 of 3 times x equals log base 7 of 32. Now that our bases are the same, they cancel. So 3x equals 32. Then just divide by 3. X equals 32 divided by 3. 10.667. What about 24?
I think you should do log base 12 on both sides. No, divide by 12. Divide by 12.
Let's divide by 12. Remember, we want to get the base that has the x, the exponent, all by itself. So we got to divide by 12. So 1 minus 4 to the power of x equals, I'll put 18 over 12 in my calculator. We get 1.5. What should we do next? Subtract 1, perfect. So negative 4 to the power of x equals 0.5. What should we do next? Divide by negative 1. So we got to get the 4, the base with the exponent, all by itself. So we're going to divide by negative 1 to move that negative to the other side. So 4 to the power of x equals negative 0.5.
I have a question.
Awesome. We're going to use logs to help us since we have exponents. So log base 4 on both sides. So log base 4 of 4 will cancel. X equals log base 4 of negative 0.5. How do we do the change of base here? Log of negative 0.5 over log of 4. What happens when you do log of negative 0.5 in the calculator? Error. So what do you think our answer is?
The extreme is the nicest.
No solution. Or DNE. Either one. No solution here. What do you think we need to do first for 25? We got to condense it. So when we're subtracting, what goes with subtraction? So log base 2 of x plus 5 over x minus 2 equals 3. Now how do I get rid of the log? Make the big base 2. So 2 to the power of log base 2 will cancel. We're left with x plus 5 over x minus 2 equals 2 to the power of 3. What's 2 to the power of 3? 8. So I'll change that to 8. What should we do next to solve? Awesome. We want to multiply by x minus 2. So it'll cancel out with the x minus 2 on the left side. So we're left with x plus 5 equals 8 times x minus 2. What should we do next?
I think you should like multiply 8 times x.
Distribute.
That's it.
So 8x minus 16. Then we can combine our like terms. So I'm going to subtract 8x and subtract 5. So negative 7x equals negative 21. Divide both sides by negative 7. X equals 3. Now with your log questions, you always want to double check your answer. What could I not take the log of? A negative. So you don't have to work it out all the way. Just lightly plug it in. See if it gives you the log of a negative number. 3 plus 5 is 8, so that's not negative. We're good. 3 minus 2 is 1, so that's not negative. We're good there too. So x equals 3 is our answer. All right, so for 28, we want to get the log all by itself. So what should I do first here? Subtract 5. So 1/3 log base 2 of x equals 2. What should we do next? We can divide by 1/3, which is the same thing as what? Multiplying by 3. So I can multiply both sides by 3. Because 3 times 1/3 would just be 1, so that cancels. So log base 2 of x equals 2 times 3 would be 6. What should we do next? I'm going to put it into exponential form. So I'm going to make the big base 2. 2 to the power of log base 2 will cancel. X equals 2 to the 6th power. What's 2 to the 6th power? 64. All right, so for 26, we want to get the ln all by itself. So what do we need to do first? Divide by 4. So ln of 2x plus 3 equals 11 over 4. I'll put this in the calculator. We get 2.75. How do we get rid of the ln? E, we're going to make the big base e on both sides. So e to the power of ln will cancel. 2x plus 3 equals e to the power of 2.75. We can put that in our calculator. So we get 15.6426. It keeps going, but I'm just going to leave it in the calculator. What do we do next? Subtract 3. So 2x equals 12.6426. And then what? Divide by 2. 6.321. Now this is a log question since it's an ln, so if you want to just get in the habit of checking your answer, it's not going to hurt you. Plug it in. 2 times 6.3 would be 12 point something, plus 3 is a positive number, so it works. All right, 30. What should we do for 30? We want to condense. What should we do first to condense? We want to move the 2 to be an exponent. So this is going to be x squared. What else can we do to condense?
And then log 4, and then x to the power of 2 over x minus 1.
Awesome. So we're going to condense with subtraction. So log base 4 of x squared over x minus 1 equals 1. What would we do next? Make the big base 4. So 4 to the power of log base 4 cancels. So x squared over x minus 1 equals, what's 4 to the first power? 4. What do we do next? Multiply both sides by x minus 1. So it'll cancel on the left side. We're left with x squared equals 4 times x minus 1. What do we do next? Distribute. X squared equals 4x minus 4. Bless you. What should we do next? I like to keep the x squared positive, so I'm going to move the 4x over and the 4. So I'm going to subtract 4x and add 4 to move it to the other side. So x squared minus 4x plus 4 equals 0. How would we solve from here? Factor. What are 2 factors of 4 that add to negative 4? Negative 2 and negative 2. So x minus 2 and x minus 2. So x minus 2 equals 0. So x equals what? 2. So x equals 2. Let's check our answer. So we got to plug it in. I could take the log of 2. That's positive, so that works. Here, 2 minus 1, is that positive? Yep, so that works. So x equals 2. Now since it repeats, you don't have to list it twice. It doesn't matter. All right, Zach, what should I do first for 27? Condense. So since we're subtracting, how do we condense? Log of x over 6, perfect, equals? Awesome, I'm going to move the 2 to be an exponent, so this is log 4 to the second power. If we have a log equals a log, what can we do? Cancel. So x over 6 equals 4 to the second power. What's 4 to the second power? 16. What should we do next? Multiply 6 on both sides. So x equals 6 times 16. 96. Now, since this is a log question, just get in the habit of checking. If I took the log of 96, that's positive, so we're good there. All right, 29, what do we do first? We want to condense it with multiplication. So log base 2 of x times 3, which I'll call it 3x, just to make it better. So log base 2 of 3x equals 3. We make the big base 2. So we're putting it into exponential form. 2 to the power of log base 2 will cancel. 3x equals 2 to the third power. What's 2 to the third power? 8. What do we do next? So x equals 8 over 3. Or if we want to put it in the calculator, we get 2.667. All right, so let's practice an exponential graphing one. So exponential, our domain is always negative infinity to positive infinity. Range is going to be whatever our vertical shift is. So here we're subtracting 1 on the outside. So that's going to be part of our range. We just don't know if it's going to go to positive infinity or negative infinity. So we'll save the rest of it for after. But our horizontal asymptote is going to be the same thing. So horizontal would be y equals -1. We can graph that. So y equals -1 would be down here. How do we find the y-intercept? We got to plug in 0 into the x. Perfect. So we have negative times 2 to the power of 0 plus 6 minus 1. So negative 2 to the power of 6. 2 to the power of 6 is 64. So negative 64 minus 1 would be negative 65. So our y-intercept would be 0, negative 65. So on our graph, we're going to stay at 0, go all the way down to negative 65, which would be down here. Way, way, way down there. But that's helpful information because we know that our graph is going to be going down. It's going to be on the bottom part of our horizontal asymptote. Now, thinking about our graph and our transformations, what does a negative on the outside do to the graph? Reflection on which axis? A reflection on the x-axis. Outside is the x-axis. Remember, if you have ex-boyfriends, ex-girlfriends, you keep them outside your house. So outside, x-axis. If I were to just like sketch this, lightly graph it, our base is greater than 1. So is it exponential growth or decay? Growth. So we'd be growing like this. But a negative outside means a reflection on the x-axis, so it flips it. So now it's going to look like this. So our graph is going to be flipped upside down. To find more points on our graph, we can plug in more numbers. Good numbers to plug in would be something that makes this 0, so like negative 6. So we could plug in negative 6, negative 7, and negative 5. So I'll start with negative 6 first. Negative 2 to the power of negative 6 plus 6 minus 1 would be negative 2 to the power of 0. What's 2 to the power of 0? 1. So negative 1 minus 1? Negative 2. So negative 6 comma negative 2 would be our first point. So we're going to go to the left to negative 6 and down 2. All right, let's plug in negative 5. So negative 2 to the power of negative 5 plus 6 minus 1 would be negative 2 to the power of 1 minus 1. So this would be negative 2 minus 1 would be negative 3. So negative 5 comma negative 3. So we're going to go to the left to negative 5, down to negative 3, which should be there. Plug in one more point to get a better idea, but this would be what our graph looks like. Remember, at 0, we're going to be at negative 65, so it'll be way down there. But this is an idea of what it looks like. So for our range, going back to our range, since our graph is pointing down, what would our range be? Negative infinity to negative 1. So remember, the smaller number comes first. Negative infinity is a super small number. Questions here? Let's do a log 1, 2. Let's do number 3, but I'm actually going to change it from the last review. I'm going to make it a negative out front. So negative log base 3 of 4x plus 1. What's our range? Negative infinity to positive infinity, so that one's a given. How do we find our vertical asymptote and domain? We set the parentheses equal to 0. So 4x plus 1 equals 0. Subtract 1. 4x equals negative 1. Divide by 4. X equals negative 1 over 4. So our vertical asymptote would be x equals negative 1 over 4. Our domain is going to have that negative 1 over 4 in it. We're just not sure if it's going to the left or to the right. But let's graph it. So negative 1/4 would move it this way. Now our base is greater than 1, right? Oh, let's find our x-intercept too. Let's put one more point on there. How do we find the x-intercept? Plug in 0 to the y. So we have 0 equals negative log base 3 of 4x plus 1. How would we solve from here? We got to divide by -1. We need the log all by itself first. So we're going to divide by -1. 0 divided by -1 is still just 0. So 0 equals log base 3 of 4x plus 1. What should we do next? We're going to make the big base 3. So log base 3 of 3. 3 to the power of log base 3 will cancel. 3 to the power of 0 would be what? 1. We're just putting this into exponential form. So 1 equals 4x plus 1. Subtract 1. So 0 equals 4x. Divide by 4. X equals 0. So our x-intercept is 0, 0. So we're going to put a point at 0 there. Now let's talk about the direction that our graph is going to open, or our graph is going to go. Our base is greater than 1. So that tells us that it was going to be increasing like this. But because we have a negative on the outside is a reflection on which axis? Outside. Reflection on the x-axis. So our x-axis is here. So it flips it along this axis. So instead of going down, it's now going to go up and this way. So it's actually decreasing. So our graph is going to look like this. Now that you guys have the change of base formula, you can plug in more numbers, get a better idea of what your graph is going to look like. But for log ones, you just need your 1 point and you need to know the direction. So you have to know that that negative on the outside is a reflection on the x-axis. It's going to flip it upside down. So our domain would be from what to what? Awesome. -1/4 to infinity. Our graph is pointing to the right. Remember, domain is left and right. So since it's still pointing to the right, it's going to infinity.